Hi guys. So today we're going to learn about the round robin scheduling algorithm, right? And how it works. So round robin, like other scheduling algorithms, is similar, but it has a few differences in the sense that we have some additional information, which is the time slice or the time quantum value, right? And this time slice or time quantum value here, it's given as 2, but this can be any other number. What is the time quantum? The time quantum basically tells us how long we're allowed to run a process, any of these processes, before moving it from the running state to our waiting again, right? For example, P1 has a burst time of 5, right? We cannot run P1 from 0 to 5, right? For 5 continuous seconds. We can't do that. We have to run it for 2 seconds maximum and then remove it, run another process, bring back P1 later, and basically keep repeating until each process is completed. How does that work? We'll see. The another thing that we have to keep in mind is the ready queue. The ready queue is to keep track of which processes have currently arrived according to their arrival time, right? And which ones are ready and which ones are going to be run next. Let's see how we use it, right? So, first of all, based on the arrival time, right, we see that P1 arrives first. So, when P1 arrives, it's ready to be run, right? So, we put it in our ready queue. And then we go to our Gantt chart, right? We make a Gantt chart and we start from 0 seconds. Now, when we start from 0 seconds, remember the time quantum tells us the maximum amount of time we can run a process. So the first process is P1, right? No other processes have actually arrived yet, right? So we start running P1 and we run P1 for exactly 2 seconds, right? So we run it for 2 seconds. And what that does is you see the burst time was 5 for P1. So that comes down to 3 now. So 5 minus 2, that's 3, right? So 2 seconds of it have ran. There's 3 seconds more left, right? Now, we've run our first process. There's something now that we need to do. We check the time, right? And we check at this time, at time 2, which processes have actually arrived and ready to be run, and that's P2 and P3. So we add those two processes to our ready queue. And once we've done that, we also see that we've already run P1. So we cut out P1 from the front of the queue and we schedule it at the back, right, to be run later. And we basically repeat this for every process, right? So after P1, we have P2, right? So we put P2 in our running state, right? And P2 has a burst time of 3. That's needs 3 seconds to complete. But we run P2 for exactly 2 seconds, right? So from 2 to 4. And this 3 is then reduced to 1 because we ran P2 for 2 seconds. 3 minus 2, that's 1. Now, after running P2, we now check the time. We see that time is 4. And we see that at 4 seconds, P4 and P5 have arrived and they are ready to be run. So we add them to our ready queue, right? We also see that P2 has been run, so we remove P2 from the back of the queue, from the front of the queue, sorry, and put it at the back, right? Now, the next process is P3. P3 has a burst time of just 1, and we're allowed to run a process for 2 seconds, which means we can run P3 for 1 second and P3 will terminate. It's over, it's completed, right? So we don't have to worry about P3, like we don't have to take it and schedule it later. We don't have to do that because it's over, right? That's great. So we just cut out P3. Next, the next process is P1 again. So P1 has 3 seconds of burst time left, right? So we take P1 and we run it for exactly 2 seconds because that's our time quantum. So after that, now this 3 has been reduced to 1, right? And our P1 is going to be taken from here and scheduled at the back. Why? Because there's still burst time left, right? Now, next is P4. P4 has a burst time of 2 and the time quantum is 2, which means we can run it for 2 seconds, right? And the process will be over. P4 will terminate. Okay, so P4 has also been handled. Great. The next is P5. See, P5 has a burst time of 3, but we can only run it for 2, remember? So 9 to 11, right? That's 2 seconds. So we run it until 2 seconds. And then P5 has now a burst time of 1, right? So it needs 3 seconds. We've already ran it for 2 seconds, so it has 1 second left. So we have to run P5 again, which is why we cut P5 and bring it to the end of the queue. Next comes P2 again. So P2, as you see, P2 has only 1 second of burst time needed, right? Left to complete. So it runs for 1 second, right? 11 to 12. And it terminates. It's done. P2 has been completed. Next, we have P1 again, right? And you see that P1 has just 1 second left. So we do that. We take P1 and 12 to 13, right? That's 1 second. So now P1 has also completed, right? Done. And next comes P5, right? So P5 has just 1 second left, which means we run P5 for 1 second and P5 has also terminated. Its burst time is done, right? So this is the complete Gantt chart and the timeline basically of the processes, right? And we can use this to find the turnaround time. Now, what is the turnaround time? The turnaround time is basically how much time a process needs to complete after arrival, right? So the turnaround time is going to be, let's say for process one, right? So process one arrived at 0 seconds, right? And after arrival, it completed at here, right here, at 7 seconds, process one. Oh wait, no, not here actually. At 13 seconds, process one completed, right? Which means process one took a total time of 13 seconds. Process two arrived at 1, 1 second, and it completed at right here. See, it completed at 12 seconds, which means 12 minus 1, that'll be a turnaround time of 11. Right now, this time doesn't necessarily have to be in seconds. I'm saying seconds for simplicity, but it can be milliseconds, nanoseconds, whatnot, right? Uh, P3 has a turnaround time, right? P3 arrived at time 2 and it completed at, let's say, here, right? Yeah, P3 completed at 5 seconds, right? So it arrived at 2 seconds, completed by the fifth second, which means it took 3 seconds to complete. And that's the turnaround time for P3. For P4, right? P4 arrived at 3 seconds and it completed, see, there's P4 right here. It completed at the ninth second. So it arrived at the third second, completed at the ninth second, which means it has a turnaround time of 6, For P5, it arrived at the fourth second and it completed at the 14th second, which means that's a turnaround time of 10. Okay, now let's see what the waiting time for all of these processes are. Now, if we notice right here, let's just bring this down here, right? So there are two ways of finding waiting time. One is turnaround time, right? Let's just say TA time for turnaround. One is using this formula that is turnaround time minus the burst time, right? You can use this formula to find the waiting time for each process, right? Say, for example, for P1, it's going to be P1 has a turnaround time of 13, right? Minus the burst time of P1, which is 5. So subtract 5 from 13, that gives us 8, right? So that's the waiting time for P1. Now we can do that if we find the turnaround time for each of them. There's another way to do this, and that is to simply come into our Gantt chart, right? And just check the the interval between every time the process has ran. So let's say P1 ran from 0 to 2, and then it ran again from 5 to 7, and then it ran again from 12 to 13. So in between these times when it ran, it was in waiting mode. So from 2 to 5, right? That's 3 seconds, right? That's 3 seconds. From 7 to 12, that's 5 seconds, right? So it spent 3 seconds here in waiting and then another 5 seconds here in waiting, right? So that's 5 plus 3, that's 8 seconds. See, 8 seconds. So you can use the Gantt chart like that, right? And you can use it to verify the other processes as well. For example, let's say for P2, P2 we use the formula turnaround time minus burst time. So P2, that's turnaround time is 11, and we subtract the burst time, which is 3, and we get 8. Okay, this one is also 8. Now let's do the same. Let's try to find the waiting time for P2 from the Gantt chart. See, P2, this is where P2 ended, right, at the fourth second. Okay, and then it waited until here and then it ran and ended here, right? So this amount of time, this is when P2 was waiting, it wasn't running, right? From the fourth to the 11th second, right? And that is 7 seconds of waiting, right? It waited for exactly 7 seconds. Now, the actual waiting time is 8. Why is that? See, it waited here for 7 seconds. It also waited. See, P2 arrived at 1 second, right? When the time was 1. So that was like somewhere around here, right? So P2 was already here at this time, but it started running at at the 2 second mark, right? At the 2 second mark, which means it also waited for 1 second here. So that's 7 plus 1, right? And that's 8 seconds of waiting. So, which is why P2 has a waiting time of 8. Now, I actually prefer just using this formula, right? It doesn't take a lot of time to find this, but sometimes the questions don't actually ask you to find the turnaround time. So some people might find it a hassle to find it, but I don't really think it's too difficult. It doesn't take much time to find this, and if you do find it, looking for the waiting time for each process becomes a lot easier because you don't have to go into the Gantt chart and just keep on checking how long each process has been waiting. That might get a bit tedious, but yeah. So let's just do it for P3, and I think after that you guys can have a general idea on how to find waiting times. So for P3, the turnaround time is 3, right? So that's 3. Okay, it's lagging a bit. 3 minus the burst time, which is 1. So that's 3 minus 1, 2. And if we come into the Gantt chart, right, you'll see that this is where P3 basically ended, right? And when did it arrive? Well, it arrived at time 2, right? So it arrived at time 2 and it started running at time 4. So there's 2 seconds between, and in this time it was in waiting, so that's 2 seconds, right? So 2 seconds of waiting. Okay. Now you can do this, and let's just do it for P4 as well. So for P4, the turnaround time is 6, right? And the burst time is 2. So that's 6 minus 2, that's 4, right? And for P5, it's the turnaround time is 10 and the burst time is 3. So 10 minus 3, that's 7. Now the average waiting time for each process is going to be all of these added, right? You add 8 plus 8 plus 2 plus 4 plus 7, and you divide it by the number of processes. Now there are 5 processes here, so we just divide it by 5, and that will give you the average waiting time. You can also do this for average turnaround time. You add all of the turnaround times, 10 and 6 and 13 and 11 and 3, and you divide it by 5. So yeah, that's how you find average waiting time and turnaround time using round robin scheduling algorithm. Thank you.